Start sharing.
So welcome everyone. This is week 13 of the class ARC 3015. As you know, we are lucky to have a guest speaker. Brent Motti is here with us. He is the Chief Technology Officer of the Turner Fleischer Architects, and he has been teaching some courses in the George Brown College during the past few years, such as Principles of BIM. I'm very happy, I'm very excited for today's lecture, Brent.
Awesome.
So it's all yours now.
All right, thank you so much, Hoda. So as mentioned, I'm CTO at Turner Fleischer Architects. This is the third firm I've worked for in my career. Previously, I was the global technology lead for design technology at IBI Group, and previous to that, I led BIM at CH2M Hill, who's now Jacobs Engineering. As Hoda mentioned, I teach at George Brown in the BIM course, and I also teach at Algonquin College virtually in their Lifecycle BIM Management course. So I love giving back to academia, and hopefully what I talk about today, everybody will find of interest. So a little bit just about Turner Fleischer, who we are. We're a firm with 46 years of experience and 185 professionals located in Midtown Toronto. So we're just at Leslie, just south of the 401. And, you know, the breadth of what we do is pretty vast. So that's what's really exciting about this firm. It's small in size. And I say that from my perspective of small being IBI Group was 2,500 and CH2M Hill when I left was 25,000. So I keep scaling by 0.1 as I go to different firms, but we still cover multiple building types. We're predominantly both planning and interiors contained within the practice as well. So the interiors group, I believe they're up to 12 people right now. So growing group, growing business. And oftentimes they have projects on their own, or they're doing interior spaces. So for example, if we do a high-rise residential building, interiors might do designs for the common spaces in the podium of the high-rise, for example. We also have a small office in Halifax providing all of these services as well, leveraging Toronto. So we have multi-office work sharing as well between the two offices. Just a couple more examples of the types of buildings. And you can see the intricacies. All of our designs are done using the BIM process. So exclusively Revit is being used as our BIM authoring tool. Like it or not, it is Revit. There are others on the market from the various vendors, but we've consolidated and we try to apply that throughout the life cycle of our projects. The biggest thing in Turner Fleischer is the culture. So regardless of the type of work we do, whether we're great architects or not, at the end of the day, it's all about the people. So I've always said the people are the greatest assets of any firm. And we have a lot of community engagement events, sporting events to provide networking across the office. Just this bottom picture is the all staff meeting, the first one I was at. So a lot of engagement. And right now, where I'm actually sitting, I'm sitting in this room right now, but it's under construction. We have a massive lab complete with a 6-screen video wall that you can see in the picture there, and then access points. Virtual reality is set up in the ceiling here, so we can very easily bring clients in, engage in technology, do model walkthroughs on the big screen, and start to engage these stakeholders in the design in a far more effective way. And here we also run what we call the Turner Fleischer Academy, or the TF Academy, and that's an opportunity for all of our employees to gain training, to be trained in various subject matters. And as a practicing architect, it allows me to gain my continuing education hours because it's accredited with my associations. So the same works for our interior designers who need NIDCQ hours. They can get those through these academy sessions as well. So very valuable to have those on hand. I teach BIM and asset management in one of the courses, focusing on the digital twin and what that means to have access to a life cycle worth of data. I'll talk a bit more about that further on. So one of the pillars of what we've push is the ability to perform research and development. So why R&D? What's so special about that? Why do we focus on that? So in our world today, and I love this graphic, I think it's very telling, the old is becoming new, things are accelerating exponentially. Those ones on the left, the slide projector and the typewriter, those were cutting edge, shockingly. That was cutting edge technology. Two on the right, what we're actually doing with the whole digitization or the digital economy, as I call it. So disruption is inevitable and it is happening. And if you just look at the state of affairs today with COVID, with the digitization of our world, really, our ability to continue to function within this pandemic was heavily dependent on the digitization and connection to technology. So look at things like Amazon, this digital transformation, all of this stuff is unavoidable. I looked at my Amazon account just for curiosity a couple days ago, and I actually opened it in 2002, which is quite impressive. I don't even remember buying stuff back then, but I maybe had one purchase a year, some years with nothing. And then I look at this year and last year, I can't tell you how many things I've purchased through Amazon and other digital providers. So that has become the mode of living right now. Groceries being delivered to your house, or we were with Loblaws, and I can shop in the comfort of my own home, peruse the app, fill the cart. I just drive there. Somebody wheels out the food to me. I don't have to go in the store. I don't have to worry about engagement or contamination or anything like that. So all those technologies are empowered by digital platforms that are in place and managed and governed by people like us. So this graph is also telling about the exponential the exponential rate of adoption. So the blue bars are when Turner Fleischer adopted something. The green bars are when the industry started to shift towards it. And how telling is this here? Here's AutoCAD, a year after I was born, 1979. That's when it came out. Turner Fleischer adopted it, 13 years later. Took 13 years from a software release to implementation within the practice. Revit, 2002, implemented 4 years later. So you can see the gap starts to shrink a little bit. And that came after, I don't know what you all know about Autodesk, but they initially released this ADT architectural desktop. It was a pretty good application. It sat on top of the AutoCAD environment. And you see that was, took 6 years for it to come in, but Revit just kind of upped the bar with respect to how we can work. And it became more about digitized components coming together versus the mantra of what AutoCAD was with drafting, the digitization of drafting. So Revit came in, a couple more. This is Navisworks. Autodesk purchased Navisworks, and it was implemented several years later. Then all of a sudden, the last 5 years happened, and things started to roll off the shelves. They brought functionality. They brought abilities to automate, abilities to interrogate data and take the interrogation, analyze the results, and use the results to feed some other function or some other process. And those things came steady and came fast. So things were released in the industry taken by the firm in a beta testing capacity, and then immediately woven into a project, and then released into our mainstream practice. And it's happening more and more. If I added a 2020 slide here, I would have things like VisiSpecs, which is an item that allows me to connect word-based project specifications to my BIM model, to my Revit, and I can start looking at how things connect. Different cloud hosting solutions are all coming to fruition. So we're starting to elevate away from the software, starting to move into software as a service, user-based connectivity to information, and just leveraging these items. You can see here in 2018, there was an explosion of virtual reality, access to Enscape, Enscape being just an add-on to Revit. Suddenly you can click a button and boom, your model is in your glasses and you have the ability to do virtual reality. So very impressive. And that as an interiors perspective, imagine you want to submerge your client into the space and have them look around, and you can do that literally with a click. Unity and Unreal allowed us to take the model and say, you know what, it's not just enough to immerse ourselves in the model, we want to actually engage the model. So imagine you're in virtual reality and you start moving things, or you bump into a virtual desk, and using haptic-based technologies, you actually feel the bump on your body by hitting something virtual. And you've seen those in gaming engines where you're in a flight simulator, and if you hit turbulence, the controller shakes, so you're getting these reactions back and forth. Well, imagine a whole bodysuit giving reactions to the design you're immersed in. So a lot of technologies that are just starting, that'll start to pop out and start to be woven mainstream into our work. So how do I do that, right? All those things I just described and so much more, you need a team. There's no way you can say, hey, Brent, design this building, immerse yourself in a project and do all the architectural work that's traditional. And oh, by the way, research, develop, redefine the practice, automate things, leverage data, etc. I can't do it all at once. So within Turner Fleischer, we have this digital practice team. And you can see the range of the types of people. So we have somebody focusing on knowledge management. That's basically taking what's in all of our brains, all of the data that feeds the practice. So the practice of architecture and the makeup of the firm. Digitize it, connect it, portray it, and let's do stuff with our knowledge. I have a manager that manages the 6-7 other people, and I just recently hired a computational designer. So an intermediate level position, and we'll talk more about this later, that will bring advanced conceptual design, automation and optimization to our practice. And then the rest of the staff here, we have those that the lead specialists, how to bring BIM leadership to projects and guide projects through things like clash detections, forms of automation, modeling practices, etc. Creation of content, which is huge. If I'm like laying out an interior space and I have to put up a big monitor wall, I don't have the content created. I don't want to spin my wheels trying to create it. So they are focused on that. Our laser scanning capabilities have started to become mainstream. So a project starts, the first question is, where's my existing data? Well, if there's an existing building, it might be archaically old data. We go scan it, we get our reference point cloud, convert the point cloud into a base existing model, and then we start our design, whether it's building modification or interior design. We develop software. So we sit back and we say, you know what? Something in Revit, I'll pick on Revit, frustrates me. So what do we want to do? We look at all the tools and we say, can I automate something? So it's simple, like placing a wall. Well, if I have all the wall types listed and they have all their data, I place the wall, it's easy. The door punches through the wall, all these automations are there. And then you hit something that doesn't automate. And then you start looking in the industry. Are there add-ons? Is there other software? Is there things we can do? If the answer is no, we go to Mosen. And we say, hey, can you build us a widget that will? Here's the criteria. He goes off and we come back with little mini programs that we add onto our software, and it's pretty awesome. And 3D printing. We want to visualize, have a physical manifestation of something we're designing, model to 3D printer to the manifestation. I just simplified that profusely. There's a lot of effort to get there, but it happens. So the concept of digital practice is a core collection of these experts with the buy-in. And this is the critical piece, the buy-in of leadership at its core, management to shepherd to the rest of staff, and staff buy-in to feedback, advise on what's needed, take what's developed, apply it on the projects and use it. And then for us, Newton is this a virtual office, if you will. It's our digital knowledge sharing center that allows us to communicate to all staff. We then have these 4 pillars: development, training, outreach, and practice. So I'll talk about development, that's where I'm going. So training, I mentioned earlier, we have this academy. We don't believe anybody comes into this firm knowing everything, or especially they won't know the Turner Fleischer way of doing things. So we bring them in, we train them on the life cycle of our projects, risk management, our bidding process, how do we design? What are some of the things we look at? How does construction administration work? How do we use Revit? How do we use Enscape? How do we obtain virtual reality, et cetera, et cetera? We train. Outreach, what I'm doing here for all of you. We want to get out there and get into academia, conferences or community events, and portray what Turner Fleischer is capable of, what we bring to the table, and hopefully generate an aura of excitement that makes students particularly want to come and work for us. Our age demographic is very young on average because we've hired a lot of students into our architectural practice. Looking at practice, I mentioned R&D, research and development, is so critical to the core values of this firm, to progress us forward, keep us current, keep us on the leading edge of new technologies, how to implement, how to better the practice of architecture. And I keep referencing the practice of architecture because my role has never been just, hey, look at new technologies and implement them. I've been an architect, a licensed architect since 2005. I graduated architecture school in 2002. So that's always been in the fiber of my being. I've worked on design projects all my life. I was on the London Olympics, Panama Canal widening, Masdar City, mass design, awesome projects scattered across the globe. And then I've also I did pump houses here in Ontario. So I've had macro and micro types of projects. All of them benefit from some type of technological implementation, but everything we do has to be molded and mapped to where it applies throughout the project lifecycle, to the benefits it brings to the architecture practice, engineering disciplines, interior design, construction managers, owners, operators. There's technology that spans the life cycle and certain areas in the life cycle where it fits. Infrastructure, so practice technology, very critical piece to what I govern here in Turner Fleischer, and it's everything from hardware to software. What's the best mode of virtual reality goggles? As simple as, in this last 8-9 months, how do we work remotely, work effectively, make sure we're all connected? I should put Zoom on this list here because Zoom has been integral to our abilities to connect. In my previous work, Microsoft Teams allowed us to connect multiple offices. And then things like BIM 360 and Office 365 or Microsoft 365 allows us to have cloud-based infrastructure for sharing of what I call work in progress files. So Word, Excel, PowerPoint, etc. Revit, you can sync a central model to BIM 360. Phenomenal technology. You can work on a Revit model from anywhere in the globe connected. There's always that issue where if you got a bad internet connection, you might have a slow connectivity to the cloud, but there's ways to optimize that technology as well. So there's a lot here alone, and I look at this and I say, my goodness, this is a full-time job, maybe 2 full-time jobs, but I molded into what I do, and the group that I govern, all of us collectively, we all have our fingers in all of these things. So a lot of stuff here, and there's so many more that could be here. Okay, development teams. So weaving into the practice, this is a critical piece. So I'm not going to go through all these names and everything, but just take note of under each of their names, their roles. So these development teams are a collection of individuals from within the studio, as well as my team. So on this Automation Nation, I've got my software programmer at the bottom here, and then somebody from residential, commercial, there's no interiors on here, but different levels, associate, intermediate, project managers. At one point we had a junior on here, and the idea here is to understand what's possible. So Automation Nation focuses on automating processes and procedures at various points throughout the project lifecycle, heavily focused in the world of Revit right now. So basically an example can be, I need to batch print multiple sheet views across multiple Revit models. So this is a recent item that was raised. And we said, okay, step one, what's out there in the industry? Not much. There's a couple of tools to explore, but I think ultimately it'll say, okay, look, let's list what we want to be able to do, get it to Mohsen, who's our software developer, and we'll start to build something, test it, and then implement it within the firm. The other thing we've explored are commercial items, heavily based in the use of Python. So PyRevit is a toolbar with a whole bunch of awesome stuff in it that this team took, analyzed, documented, and deployed. And then based on that, we know what's there commercially, and we know how to drive things within the firm for non-commercial development. And everything we do, there's a purpose. So we're not just building stuff for fun or saying, hey, let's automate this just because we think we can. It's something within the workflow of, I have a model, I have drawings, and I have to deliver. There's a whole bunch of things to happen in between. Technique, this is a team that I lead, and the focus here is being able to understand and rationalize, quote, our technique. How do we do things? What technologies do we use to better our practice, better our firm? Let's capture that and portray it on our website. I'll jump to our website in a moment, but that's the role here. And, you know, I don't know what everybody is doing, but with this collective team, and notice here we have a marketing specialist. So this collective team, we say, I'm a believer, I use Power BI a lot. So I say, hey, look, I can grab data from one source, data from another source, mix it all together and report. Awesome. Now, how do I tell that to the outside world and make it look very awesome? Marketing comes in, takes the ideas, takes our content, weaves their magic, and we have something to portray on the outside. Virtual reality, it's focusing specifically on the role or the need for visualization and how that manifests itself in our practice. So started with virtual reality, so we said, hey, let's immerse ourselves within the designs that we're creating. Enscape was a huge win. Kudos to those developers. So if you never heard of Enscape, it's just basically an install add-in to Revit, SketchUp, Rhino, or whatever, a couple others. Those are the tools we use. And basically I model something, click a button, and it's in my VR. Phenomenal. And then we look at standardization of material libraries. So your brick and my brick are the same brick, your paint and my paint, your wood and my wood, and then we have all the possibilities. Let's standardize on the possibilities so we're speaking the same language, visualizing the same thing. We're more optimized, we're doing better on our budgets because we have that optimization, and it all trickles through to the bottom line. Facilities management, I lead this one as well, and this is one of my passions. So here, this is the concept of bringing together all of the data for all of the assets that you're exposed to and allowing us to understand performance, manipulate the assets, and give us intellect into what's called CapEx or OpEx, capacity expansion, operations expansion. And the example I'll use, I'll talk through my house example right now. I very recent, like this year, 2020 was the year of crazy. 2020, at the start of the year, I basically automated all of my lights. So I did some exploration on unique bulbs, things you can plug in, and I ended up actually changing all my switches using the Lutron system, and I can access everything via my smartphone. I can program things. If one light does something, so if a bathroom light goes on, I can force the fan to go on without having to connect the wires and everything, and it's pretty phenomenal. The benefit of that, I basically, from my phone, I can log in, I can access, I can understand usage, I can start to see performance information. If I connected that data to the cost of electricity where I live, I can start to see when I'm spending more money connected to my lighting and when I'm not. I can see patterns of how my family uses lights. Then I can start to look and imagine this where you're living or in whatever room you're in. If you look up and you can see there's horizontal light fixtures behind me or above me. If I needed to change a bulb, and now we're getting into the specifics of an operator. If you called me to your house or your home and you said, change that light bulb for me, I wouldn't know what to do. Obviously, unscrew a light bulb, screw in a new one, but I got to get up there, look at what type of light bulb it is, go procure the light bulb, then bring it and install it. Okay, there's quite a bit of effort there. If I pointed my phone at the light fixture and I was able to access a digital twin, and that's the concept there. So a digital twin is my virtual 3D model, or my BIM, with all the information. So I point at a light fixture and I want to know, what is the fixture? When was it installed? What bulb does it use? How often was the bulb replaced? Then if I know the bulb, I can immediately order it via Amazon, same day delivery. It comes to me. I don't have to go anywhere. I'll just get the bulb. But then I could start to think and say, okay, hold on a minute. That's an LED fixture. It's supposed to be rated for a 20,000 hour lifespan on its bulb. And I'm replacing it now for the second time. These bulbs are only lasting 1,000 hours. Why? And I can start to analyze that. And maybe I can get information from the power grid to understand, are there power fluctuations, things that are affecting the ballast or the internal working of the LED fixture itself. Maybe I have an issue of electricity coming in. Maybe I have an issue at the box where the fixture is connected. Maybe it's not grounded properly. Maybe the neutral wire has been compromised. Who knows? And I can start to ask all that information and then intelligently declare, I will replace the bulb, or maybe I'm going to replace the fixture. And that's what I went through in my house. I had old fluorescent lights in my laundry room, took it out, put an LED, control it in an automated fashion, and I have all this value. So phenomenal story. I look at that and I say, this can apply to anything and any asset you see. So what we did under FM, we also connected the FM research to academic research, engaging into NSERC grants and allowing us to bring students on funded by the NSERC grant obtained by a college, and allowing us to work with the students to help develop these concepts. So these are 4 grants that we pursued in the last couple of years, and grant number 4, I'll talk about that after, sorry. I have a slide of that, but grant number 4 was connected to facilities management. So there's always that opportunity. If you say, well, you know what, Turner Fleischer seems like a cool place to be at, but there's no job postings. Well, there could be grants that we are actually actively pursuing now as we speak to be able to connect students to some of our more advanced work. And oftentimes these students who came in on grant co-ops would eventually end up being hired as well. so long as you're awesome, which I'm sure you all are. So what R&D are we doing right now? So we'll come back to facilities management in a moment. Just checking time. Okay. One of the biggest items we had was connecting, for us, this Clearview, InFocus, and Revit. Clearview is our financial system. Revit is our BIM system. And the reason to do that is there's different pieces of data. So our finance team, they work in Clearview. We have Revit. Finance has a whole host of items specific to the project and the employee. And they manage who has access to what data, how that data flows out, and how that data is fed in. So a lot of inputs and outputs to that system. Revit, we need project data to initiate our project setup. We need people data to run audits of our models, ensure things are modeled as they should be, and connect back to staff and managers and project managers when there are issues to fix, and then hold people accountable to have them fixed. Content request and support ticket, those are two items as well. So within our software, if I have an issue, I don't have to jump to my email, find who to send an email to, etc. We just have a help button. Click it, boom, this thing pops up. I type in my issue and I hit send. Well, that has to pull my employee data, who I am, what I'm doing, why I would be doing that, what authorities I have, and then pass that along either to the person to make the content or the person to take the support. And that used Revit, Excel, connections to Outlook, pushing everything through SQL. SQL is powerful and amazing. And if you haven't heard of Microsoft Azure, Azure is their cloud-hosted environment that allows you to actually create and host SQL servers without needing the burden of physical hard drive. So you can have the benefits of SQL through the cloud. And then Power BI, I discovered Power BI, 18 months ago now. I think that's right. No, maybe more like 30 months ago, I think. And it changed my life. I can take a piece of data from anywhere, Revit export it out, financial system, SharePoint, a simple spreadsheet, whatever it is, and visualize and understand that data. So very powerful. And here's all data fields that are all connected. So you can see here, to create a new project, we need a whole host of employee information and project information. To create content request, who's the person submitting, and then for what project, right? So simple, it seems simple, but I can't tell you, without the connection to the data, you call the project X, I call it X+1, everything's different, nothing connects, and you have a disaster on your hands as time passes. So then we looked at how to roll this out, and we said, okay, there's a lot of stuff here. So this is a rollout process for any type of automation within Revit. And we said, and don't get hung up on this, what I want to portray here is some items we looked at potentially close to 400 hours of effort, depending on how extensive these items are. And you can see here, standardized project information that comes from all that project data being pulled in from Clearview. But that's just one piece. We've automated that connection. Now there's all these other things that have to happen. So we said, what do we do? So we said, let's engage these development teams, the people that are actually experiencing these complications, and how do we better what we do? So we said, let's find areas for possible automation. So in this workflow, what can we automate? What can we get rid of? What can we do more efficiently? Dynamo was introduced a couple of years ago. Powerful tool, maybe 3 years ago now. We attended Built North America a couple years ago, discovered the power of the journal files. So we said, let's analyze that, build some Dynamo scripting, and plan a rollout. So what happened was this became this. We cut out a whole host of hours, saving 150 hours for potential rollouts and implementation of these types of projects. And this here is just efficiency derived from automation. And that's a very powerful ability to have. And it's something that we're only going to get better at as tools become better, as we become better, and we keep growing within this environment. Now back to FM. That's John Chow. He's one of our partners, and he was the FM person. Every question flowed through him. So a year and a half ago, he almost retired. Where would all those questions go? And there's, see, light bulbs right there. That was the example I was giving you about my home. And that's just one of many. I also automated my thermostat so I can now access my home heating and cooling via my phone. Don't ask what happens if my phone goes dead. That would be scary, but there's still manual interventions. But the point is, it's the digitization of the world. So that NSERC, so that academia, this was the fourth one. When they came in a couple of years ago, they said, okay, what can we do? So this is getting into the digital twin. It's a very coined phrase right now, but a digital twin is essentially your BIM, so your 3D virtual model with all the data housed in there, all the information outside of the model pertaining to the asset. So shop drawings, operation manuals, warranties, payment information, etc. And performance data. That's the biggest, performance data. That's huge. All of that comes together in a system, giving us the ability to have a contextual input to our information via an iPad, whatever, phone, and I can do stuff with it. So the light bulb burnt out. I should be able to point my phone, say needs a new light bulb on that fixture. That fixture has a QR code, an asset name, it's connected to all its data. The need for the light bulb gets sent to facilities management. The repair person gets it, the part is ordered, we've analyzed performance data, we validate, yeah, we just want a new bulb, the fixture's still good, and all of that happens. The person shows up on site with the bulb, with a ladder or a scissor lift, changes the bulb, done. One visit, all complete. And from the user's perspective, they've just pointed a device and said, please fix, and a little more data, but all good. So how we work. Okay, I'm still good on time. Let me hit this link here. So now this takes you directly to our how page. And if you go to turnerfleischer.com/how, this is what the technique team works to build for you, for the external world. So here's an example of a quote, simple computational design, front end of design, what can we do? How big of a podium, how high should these high-rise buildings be? What's the effect on the calculated gross floor area or GFA? And let's make a decision. Is there something we want to optimize? We can further analyze it and actually get something going on this. So simple in concept, pretty rich in data definition, and then it appears. Design review, we're able to see what the model was and what the finished product is. So there's a lot of examples now where we're able to look at what actually is physically built and see how close we were, and you can see it's pretty spot on when I hover over these, what happens. And then when something's different, like those two tables there, they became shelves. But that's fine, there was still an item there, an asset to be modeled, and then it was just decision making. Now the ideal world is you go back and change the model, and then things are good. The other one I wanted to show was real-time visualization. So this is a SketchUp model, and then at the bottom is Enscape inside the VR lens. And you can see as we're changing items and adding pieces to the SketchUp model, you could be my client in the VR goggle having a full experience of what's being changed. And then you could tell me, no, you know what, yeah, put marble on, white marble at the bottom, brown on the top. I'm doing it, you're seeing it, you can look around, experience, and be immersed in it. So a very powerful design tool and very powerful ability to engage the audience and let them fully understand what we're intending to do. The only other one right here, and again, please go to the how page. It's a pretty awesome page here. Asset management. So this is embedding information. So it's not just about modeling components, but understanding what they are. So I can look in here and hover over any one of these. So I have a deli case, a decorative wall, the produce bin, lighting fixture. My lighting, I got a thing for lighting fixtures. And it tells me the information about the fixtures, some particulars, particulars about how high they are from the product, how many there are, as you can see in the plan, they're highlighted, and I can engage in this information in a very simple and interactive way with our clients. So some powerful stuff there. Okay, the last debate here, I want to talk about computational design and the importance of this role. So this is what I posted a couple weeks ago. As I said, we just recently made the hire. She starts in a week and a half. I was looking for somebody that initially had experience, so that's why I say it was an intermediate hire, someone to start to build this facet of the digital practice. So as this grows, and I'm going to show a bunch of examples now, as this grows, then there could be juniors brought on. I was specifically looking for Rhino, Grasshopper, and Dynamo Revit combinations, where like I don't want somebody coming into the role and saying, I've never heard of these tools, but let me learn. At the intermediate level, I had to have proven experience. Attention to detail, ability to work under pressure, tight deadlines, this is pretty standard in the industry. But what set the candidate apart was the portfolio. So when we interview you, when you apply for any one of our TF roles, have a portfolio. If you're applying for interiors, have a portfolio of interiors projects plus others, but you need interiors. Computational designer, I needed to see examples of computational design, and I was looking for those that were rooted or easily applicable to the profession of architecture. So I wasn't looking for academia, twisty, curvy, funky things. That shows you can use software, but I needed to understand that you could rationalize the software capabilities to the practice of architecture. So I'm going to show some examples if you're sitting there saying, huh, what do you mean by that? So what I'm going to do is I'm going to start, sorry, I wanted to preface this before it goes. I'm going to start from inside the building, interiors examples, and spread out to the neighborhood or city level. So this first example was basically an office space that we were doing an interior fit out, and this was done by my previous employment at IBI Group. And we built parameters to space the desks, so allowing for proper clearances, allowing a minimum how they can go so far together and so far apart, they couldn't be on top of each other, clearance from the columns, etc. And then we allow the tool to optimize and say, based on all of our criteria, which arrangement would allow for the most number of desks to be placed within the space. And as you can see, the optimizer, it's going through, over 500 possibilities, and it's going to stop when it finds that right location. And then we said, you know what, just for fun, let's look at placement of printers and have a maximum walking space to the printers, a certain number of printers, and let's optimize their location. So the optimizer looks at the possible arrangement for all of these, and will eventually land on the most optimal as determined by the computer. And then we have the opportunity to peruse and analyze any one of these solutions, let me pause there, that are relevant here. Closer to the top is the most optimal. We can then sit with a client, go through all of the permutations, identify either the most optimal or those that could be preferential, isolate them, come to a design decision, and all of this can happen within hours instead of days or weeks. So very, very powerful there. Next, I'm going to look at parametric storage facility optimization. So this is a storage facility. There's a proposed extension. There was criteria not to interfere with the existing envelope. There were certain racks of storage bins for incoming cargo, and then a proposed extension to store the cargo for outgoing shipments. And basically, we plugged in the rack sizes, the bin sizes, and we asked the optimizer to try to lay them out, maintaining a certain minimum number, and show us what that footprint might look like to contain these racks. And there was only so high they could go as well, so it's a single-story building. And notice the options, you're looking at a full L, simple L's pulling out to the third grid, and it's trying to find what the best is, and eventually it lands on something as it can't find anything more optimized. Oops, sorry, I wanted to pause there for a moment. Let me go back. So, looking at this, we now can, again, cycle through the possibilities, see the options. Maybe the client wants the one where it came out to the third grid. We can explore that. We can understand that it's a little less optimal, but maybe the one to proceed with. And it just allows us to have the dialogue and to portray the possible solutions in minutes. Once the grasshopper logic is built, once the parameters are defined, then all of a sudden the ability to achieve this is easily realizable. And getting these options running, letting the computer do the thinking for us. Now, somebody once asked me, well, does that remove our job? No, because I have thousands of permutations here. There still needs to be design thinking, critical thinking, if you will, engagement of the client, engagement of the industry to understand what we're proposing. Operationally, will this work? So who are the operators? Who are the clients? How do we engage? How do we come to the decision? It's not just, oh, here's the last one, let's do it. We have to understand. So now let's step back a bit. Solar exposure on a building facade or on a roof. So what we did here is we looked at the solar exposure rating across the various months in the year and understood when the roof and that facade would have the best exposure and when it wouldn't. And then what's the ramification of a new design? So we looked and said, hey, if there was a new building that was put in that view, it would harm. Over here, it would be less harmful. So by this analysis, by the ability to float this building around, we can look at the future potential design. We could look at future potential design around our project, look at the design of our current project, make sure the client understands, you know what, the most optimal is your roof. It will perpetually be getting sunlight. Even if taller buildings are casting shadows early in the day, it'll still get sunlight on the high noon peak periods, and it'll still get solar gain. So then we have a logical discussion. This project specifically was, do we want solar panels on the walls and on the roof, or just the walls? And we can say, can we ensure there will never be a building placed over here blocking our solar gain? If the answer is no, then you have a logical discussion of, well, you know what, in 15 years you might have zero solar gain. Is that acceptable? And you can start to have that dialogue. It can mold the design decisions. Maybe we increase roof space. Maybe we build a connectivity between these two buildings up on the top, have much more roof, much more solar gain. There's all these potentials, but it's all sparked by the ability to portray the idea and portray what can work and what might not work. Okay, this one here, this was Untitled Toronto, and it's sold out now, but the idea was to take, it's a building with Pharrell as one of the owners, and we took his song Happy, and we mapped the rhythm of what the sound wave was doing. Once we had the rhythm mapped, we turned it into orthogonal shapes. So this can now be built. And then we applied it vertically. And we said, this is how the rhythm could flow across the facade. And then we said, how do we show that now? So we said we would show the rhythm using treatment to the balconies, both the balcony slab and the railings. And we would build in the rhythm. We would take a static snapshot of it, build it into the handrail, resulting in a building that conveys the song Happy in the fiber of its built fabric. Pretty fun project. it went from 0 to 30% quite quickly because the concept was understood, it was imagined, it was based on the music, it resonated with the client, resonated with the community, and it had a very early buy-in for the work. So again, the possibilities is all I'm showing you here with computational design. Let's step further back now and look at the building as a whole and its impact on the community. So here the question was, how do we understand, or let me pause it, how do we ensure that anything built in this space casts no new shadows on the park? That was the criteria. So we basically analyzed the movement of the sun at all times of the year to map the shadow and then understand what built form could be housed within that shadow line, thus giving no new shadows. And to show here the building behind, that's the controlling mechanism. If we moved and played with it, the shadow form would adjust. So based on this, we knew the outer constraints of our building. Once we know the outer constraints, we can then map an orthogonal or curved built form, something that's realizable within that constraint. So it didn't have to be those funky shadow angles, but we can guarantee that what was designed will cast no new shadows because it was housed within that shadow line that the algorithm told us. And then once we had that, we were able to analyze facade treatments, play with windows and mullion spacings, and understand the wall to window ratio, and have quick calculations of the percentage of that to see if we wanted to optimize that or make that better, and allow that to inform our design based on aesthetics. So aesthetics with a functional analytical output, all driven by the tool itself. So just be mindful of time. I have 2 more here, I think. 3 more. Floor to area ratio, FAR. So this allows us to look at the analysis of, let me pause, where we can have high floor area ratio versus lower. So imagine floor area ratio is if I go 2-3 stories high, I'm covering more of my site. Gross floor area divided by site area. And then we have these force factors. So if we adjust them, we can say, well, maybe we want minimum area to have a stronger impact. So as we drag those forces, it builds that gradient from which I can go from minimum to maximum. And then it allows us to analyze and understand, so let's say this was on a downtown street. Maybe I want the maximum facing the street and have it taper back a little bit, but still max. And then as we move away from a central point, we get less and less dense, decreasing the FAR. And it's just an analytical tool to allow us to think about neighborhood development and how beneficial that neighborhood development, what benefits the development could achieve from various types of density. And then sticking with density, at a larger neighborhood level, this is an analytical tool, again, Rhino Grasshopper, allowing us to analyze the return on investment for a potential development, high rise to mid rise to low rise, based on the cost of housing it in the vicinity of a transit station. So the closer to the transit station, the more dense we want. But if we increase the density going further out, that increases the return on investment for the developer, and then that allows for cost sharing to the neighborhood and the transit hub. So that's what this is exploring here. And as you can see, it's just, again, a neighborhood development tool allowing the client and the community to visualize and understand what the impacts are of these designs. So imagine if this was your neighborhood and you were asked, do you approve this or not? Well, you could look at it and say visually yes or no, but wouldn't it be awesome to understand the cost impact and the return on investment time required, how much residential, how much commercial, what's the increase of people, etc., all that data from an engagement tool like this. And lastly, thinking of engagement and immersion, when I was at IBI Group, we explored Parametric design coupled with augmented reality. So one of my computational designers worked with one of my visualization staff. They found a tool called Fologram, I think it was called, that allows me to take a grasshopper rhino model, portray it through a tablet device or a HoloLens. So I have here, you just saw in the tablet, this is seen through the HoloLens. So you can place the model on a conference room table, on the floor, engage with some of the adjusters that were told to go from the grasshopper environment into the augmented reality. And as you're making these adjustments, the model is changing in front of you, and you can also shift and adjust some of the geometry as well. Force attractors are affecting density, so height, etc. And yeah, it's just a totally different form of engagement that you can actually even bring up to a one-to-one scale. So very quickly, stakeholders, the community, the client can get a feel for the space and an understanding for what the impact is for macro level design decisions. And once this is understood and accepted and move forward, then it'll just enrich the rest of the design process, allowing us to fully understand what decisions were made, the positive impacts, and then proceeding to construction documentation, tendering, and then building, actual build out. So that's all the examples I wanted to show. I'm pretty good on time here. Last two slides. When we go around in conference, we talk about lessons learned for a dedicated approach to R&D, and some critical items here. First, we need top-down support. So I report to the CEO, and then to me is the entire digital team, and then I have lateral connectivity to the entire studio. Leadership needs to be invested in this process. We're going to research, we're going to learn, we're going to develop things, we're going to eventually have direct benefits to how we work. It's a fallacy to believe you can work on projects and implement innovation concurrently. So as I said at the beginning, if I was doing massive design work continually, when can I innovate? When would I have time to research? The timing doesn't jive. R&D strategy must be aligned with the goals of the firm. So we want to be trendsetters. We want to be ahead of the curve. We want to better our practice. We want to deploy technology. They're all goals that we possess. The scope of these initiatives exponentially changes, and failures will occur. So if you're a Star Wars fan, if you saw Last Jedi, what did Yoda say to Luke? Failure is the path to learning. I'm not going to do his voice or his exact words, but failure is important. So somebody in HR once told me FAIL stands for first attempt at learning. First attempt in learning, sorry, fail. So that's the philosophy. We're going to try things. We're going to fail. We're going to learn from errors. We're going to better ourselves, and the net result will always be betterment. Okay, we don't give up because we fail. The scope of initiative, use project staff to beta test results. I can't work in a vacuum. That's why our dev team come from the studios. It comes from the teams that will use these day to day. They feedback, they experiment, they let us know what's working and what's not. Attend conferences with a purpose. Don't go just to go. Take things that make sense. Explore. Give back to those around you and make it a better place. Adopt an incubator mindset. Give staff the opportunity to step away from the day-to-day. That's our dev teams. That's our engagement. I don't want you staring at a monitor all day inside a Revit model and not stimulating the mind. We have to allow that, facilitate that. The more staff know, the more they'll embrace change. I want to hire people that are smarter than me. They're the experts. They feed me. I feed them, and change occurs. Don't expect your return on investment to be measurable. And most often it's not measurable at the beginning. And I always say there's things to assess the non-quantifiable value. So did it bring betterment, ease, reduce stress level, make the people happier? Those are the types of things that bettering wellness as well as creating financial value are all good things to have. And lastly, R&D is essential to future-proofing a practice. If we were still a firm that used the drafting board and T-squares and set squares and pencils, I don't think any of you would apply to work here in the future. So we got to keep getting better. We're redesigning our space to implement better technologies, to keep getting better, to hopefully be future-proofing our practice for a certain period of time. And that's everything I had. So I'm going to stop sharing, and I'll ask if there's any questions or comments.
Thanks, Bernd. Great as always. Excellent
Thank you.
examples. Very helpful. It kind of shows the big picture. So we have been working with Dynamo Revit all the time this semester, but getting the big picture is a whole different thing. So thank you very much.
My pleasure.
Any questions?
Thank you, everybody. Well, if something comes up and you think, feel free to send it to Hoda and she'll send it to me. And yeah, it was my pleasure to present today, and I hope you found it insightful. And yeah, have a good rest of the day.
Thank you very much. Excellent. Thank you.
All right.
Take
Take
care.
care, everybody.
Thank
Bye.
you.